Hi, everybody. This is your video on the standard normal curve and normal probability calculations. And so in this video, I'm going to show you how to use the z-table and how to do some of these normal probability calculations. Um, and then I have one more video for you in this section on normal probability plots. That one will be shorter, but I'm also going to put a couple more practice type problems with the normal distribution and the normal probability distribution in that video. All right, so let's go ahead and jump into it. So in the past videos for this unit, both in this section and in the last one, we've talked about percentiles, which is the percentage of data that lies below a certain value. I showed you how to calculate z-scores in order to do comparisons between data sets. And we also talked about this standard normal curve and all of those things. So this is the video where we're going to put all of that together into one idea and use all of those skills to calculate probabilities, which is the most common thing that normal curves are used for. Okay, so in the last video, we were talking about the empirical rule, which is the 68, 95, 99.7 rule, which we use to figure out, okay, what percentage of data lies between certain X values. And most of them were within 1, 2, and 3 standard deviations of the mean. So you can use that rule. Most of the time, though, the X values that you are given won't fit really nicely on these 1, 2, and 3 standard deviation tick marks along the x-axis. So you can't really use the empirical rule for those things. So in those instances, instead, we have to use a standard normal curve, okay? The standard normal curve, which has a mean of 0 and a standard deviation of 1, okay, so a mean of 0 and a standard deviation of 1. Oh, I completely covered that. Let's try that again. Okay, this is the curve, the normal curve that we know the most about, right? And we are able to calculate probabilities for any value, any X value along the X axis down here at the bottom, okay? But most of the curves, the normal curves that we deal with are not standard normal curves, right? So we have to do some conversion, right? That's what the z-score is for, to convert values into the standard normal curve. And once we do that, then we have tools that we can use, like the z-table, and there's a function on your calculator that will do this, that will show you or help you calculate the probability of getting a value, less than a certain cutoff point, greater than a certain cutoff point, or between two values. Okay, so we have a table that we can use, like I said, as well as a calculator function. I'm going to show you how to use the z-table in this video, and then I will post links to other YouTube videos made by other teachers that will show you how to access those things on your calculator, okay? So keep in mind that the area under the standard normal curve, okay, to the left of a particular value is the probability that that random value will be less than or equal to that value. Okay, it's basically a percentile. Okay, right? So for example, the area to the left of the mean is always 0.5 or 50%, because the mean is the halfway point in a normal curve. Remember, when we talked about density curves in the last video, I told you that for standard normal curves, the mean and the median are the same. They're in the same spot, Okay, and then we have to remember that the area underneath the entire curve is always 1, or you can think of it as like 100% of the data. Okay, if our variable doesn't have a mean of 0 or a standard deviation of 1, we have to take all of our values and convert them to standardized values, which are z-scores. Okay, and the reason we have to do that is so that we can use our standard normal tools that we wouldn't otherwise have access to without that. Okay, right? If you recall from the last section, I kind of went through like what the standard normal was and what we're actually doing when we convert something to a z-score, when we standardize something, right? In other just any random normal curve, right? Say I have a normal curve with a mean of 2 and a standard deviation of 0.4, for example, right? All of these values along this axis are x values. Okay. When we complete a z-score, what we are doing is converting to a standard normal, the standard normal curve where the mean is 0 and the standard deviation is 1. Okay. And we are converting our x values and we're changing them to z values. Okay. All right. So let me clear this off. Give me a second. Let me clear this off and switch some things around. And then we are going to talk about the z table and how to read it next. All right, y'all. So let's talk about the z table. Okay. The z table is also called the standard normal table. What it does is it gives us z values. It gives us a list of all possible z values down like to the hundredths place from about negative 3.5 up to positive 3.5, because that covers most of the data in a standard normal curve, right? Because if you recall from a previous video, remember I told you that when you have a normal curve, that most of your data, remember this is from the last video, most of your data falls within 3 standard deviations of the mean. If the mean is here in the middle, okay, that you have most of your data, 99.7% of it, in fact, that's within 3 standard deviations. Okay, and if then if you remember from the previous section when I was telling you about z-scores, standardized scores, and what they are, okay, 3 standard deviations is like a z-score of 3, right? So a z of 3 means 3 standard deviations above the mean. Okay, and the z table goes all the way out to z equals 3.5 and negative 3.5, right? So that's going to cover almost all of the data in a standard normal curve. Okay, so on the outskirts of the z table, which you can kind of see here, right, you have z values, okay, and then in the middle, you have probabilities. Okay, those are all probabilities, and they are the probabilities that you would get a z value less than that particular z value that you're looking at. Okay, the z table is almost like a table of percentiles for the normal distribution, the standard normal distribution, right? Because the z table is always going to give you areas to the left of a particular z value. Okay, which I need to write over here on this side. Okay, area given is always to the left of that particular z value. Okay, so you will have to do some subtraction or look at a slightly different number on the z table if you want to find an area to the an area to the right or a probability to the right. Okay, so I'm going to switch over here, and I'm hoping that you can see this. You should be able to. Ooh, no, too far. Okay, so what you would see here is the Z table. Okay, so let's say, for example, that I want to find what's the probability that Z is less than, I don't know, 0.72, for example. Okay, this right here, by the way, that I've written in green on the right-hand side of your screen, is called probability notation. Okay, whenever you do Z problems and normal distribution problems, you'll have to include probability notation like this so that way the reader knows and has context for the probability that you are reporting. Okay, so if I want to find the probability here that Z is less than 0.72, so what I'm going to do is I'm going to zoom in on this side. Okay, so the first thing I have to look at is this column, okay, and look for 0.7. Because remember, my Z value is 0.72, okay? So this first column here will give you this value, right, the 0.7, which is right here, okay? And then in that row, you'll see there's 10 different probabilities, one for every hundredths place that is possible for 0.7, okay? So this part comes from this top row, okay? So this value here, 0.7580, is the probability associated with Z equals 0.70. This one is the probability associated with, oh, hold on, let me change my color here. Okay, this one is the one associated with the Z value 0.71. So the one that I want is this one that's associated with Z equals 0.72. Okay, so this number, the 0.7642, that number is the probability. That is the probability that Z is less than 0.72. Okay, so if you think of your standard normal curve almost like a dartboard, okay, there is a 76.42% chance that if you throw a dart, right, and you pick a random number along the Z axis down here, there's a 76.42% chance that you will hit a number that is less than Z equals 0.72. Okay. If I wanted to find, for example, a value, so let's say, so this number here is the probability that Z is less than 0.72, okay? Say instead I wanted to find the probability that Z is greater than 0.72, okay? If this area is 0.7642, right, and that's the area that's less than 0.72, then that means this area, the area above, has to be 1 or 100% minus 0.7642. Okay, so that is, so it's 1 minus 0.7642. Right, so it's 1 minus whatever the number is you get from the Z table, which is 0.2358. Okay, Another way that you can get that number is you can look at the negative version. Oops, let me erase this here. Okay, you can look at the negative or the changed sign version of the z value, which is, oh my God, sorry, lost track of my pen, which is negative 0.72. And that value is right here. See that? So same number, right? 0.2358. If we scroll back over, that's exactly what we got here, 0.2358. Okay. If the original z value was negative, right, you would have to go over to the positive version of that z value if you were finding the area to the right. So it's always just the one with the opposite sign. Okay. So that is how you use the z table. All right. So give me a second to clear this off and rearrange my screen a little bit, because I'm going to do a couple of examples for you using the table here. All right, y'all. So I've zoomed in a lot on the right-hand side, and actually I'm going to do this and make this a little smaller here so that you can see this a little better, hopefully, on the right-hand side. So whenever you are asked to do normal probability problems and calculate probabilities, okay, there are steps that you follow. Okay, so these are the steps that you follow. 1, sketch the curve with the mean and the standard deviation shown. Okay, so I'm going to do that first. So in my first problem here, I'm trying to find the probability or the area here that z is less than 1.39. That's what I'm trying to find. I'm trying to find a probability here. Okay, so I'm going to sketch my curve first. It does not have to be beautiful, right? Mine usually look like this, but you always want to just sketch out the curve real quick, label the mean, and the mean here is 0 because we're looking at a z, right? Z distribution, the mean is 0 and the standard deviation is 1. Okay. Next, okay, step 2, shade the area of the curve that we're trying to find. So 1.39 is here-ish, okay? It does not have to be exact, not even close. This type of sketch is perfectly fine, okay? And if I'm trying to find the probability that z is less than 1.39, I'm going to shade the area to the left of that z value. Okay, that's what I'm trying to find. Okay, you don't have to include anything else, right? In the previous video, when we did problems with the 68, 95, 99.7 rule, I made you write out like all three, like all the standard deviations down here at the bottom. You don't have to do that. The reason that we do the sketch is so that the AP readers, when they go in and look at this, even if you calculated incorrectly, they know that you know what area you're looking for and how to find it, right? So you can get a lot of partial points that way, even if you mess the calculation up, okay? So next step when we're doing this is usually to calculate a z-score. We don't have to do that here, okay, because this is already, it's already a z-score. Like this value here is already a z-score. Okay, but I'm going to do some examples for you in the next video where you're going to start with an x value rather than a z value. Okay, so we don't need to calculate a z-score. It's already calculated for us. Okay, so what we are trying to find here is the probability that z is less than 1.39. Okay, so I'm going to use my z table, right, and look for the probability associated with 1.39. So I'm going to look for 1.3, which is right here. Okay, and I'm going to count over. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's my probability, 0.9177. Okay, and that's my final answer here, 0.9177. And that's it. You can leave the problem exactly like that. Okay. You don't have to convert it to a percentage if you don't want to. This is perfectly fine. Most of the time, probabilities are left as decimals rather than converting them to percentages. Okay. All right, so let's look at the second one here. Okay, so same thing, we're going to follow the same steps. Okay, so I'm going to sketch my curve. Okay, my mean is here in the middle, and it's 0, and my standard deviation is 1. Okay, and then here I'm trying to find z is greater than negative 2.15. So I'm going to say negative 2.15 is here-ish. Okay, and I'm finding a greater than probability, so I'm going to shade this whole area above. I'm going to shade to the right. Okay, so what I am finding here is the probability that z is greater than negative 2.15. Okay, that is the same as 1 minus the probability that z is less than negative 2.15. Okay, the reason I'm writing it this way is because, remember, the z table is always going to give you these values. Okay, the less than probability is what you get from the z table. Okay, so let's hop over to our z table and find that. So let me clear this off. Okay, all right, so my number is negative 2.15. Okay, so I'm going to look for negative 2.1, which is here. So negative 2.1, and then I'm going over to 5. So this is 0, 1, 2, 3, 4, 5. Okay, so 0.0158. Whoops, hold on. Okay, so this value here is 1 minus the probability from the z table, which was 0.0158, and then you just have to do that subtraction. So that is 0.9842. Right, and that's my final answer there. That is my final answer. Okay, another way that you can do that is if you look here, rather than looking at negative, oops, sorry everybody, rather than looking at negative 2.15, I could look at the opposite of that, which is positive 2.15. And the reason I can do that, right, here we go. So 2.1, 0, 1, 2, 3, 4, 5. The reason I can do that is because this is symmetric, right? And the area in the tails is the same. So you can get and look at the opposite if that's a little easier for you than doing the subtraction. Okay. All right. So last one here is a between probability. So when you are doing a between probability, the rule is you find, oops, I really should do this here. Okay, so find the probability for both and subtract those probabilities. Okay, and here's why. Wait, hold on. Here's why. So I have my, oops, sorry everybody. I have an alarm going off. Okay, if I draw my distribution here, okay, this, and then I label my values. So here's negative 0.56. My mean is here in the middle, which was 0. My standard deviation was 1. Okay, and then my upper number is 1.81. Okay. The probability that we get from the z table for this number will give us this area, right? Because it's the area to the left. the probability that we get from the z table for this number, the upper number, will give us this area. It will give us this whole thing, right? So if we take the blue area, which is this whole thing, and subtract out the green area, it will give us just the area that we care about, which is this middle between area, okay? So if you look at the z table, the probability associated with this number, this z value, 1.81, okay, is 0.9649, okay? And then the probability associated with this z value, the left probability, negative 0.56, is 0.2827. So I need to subtract those values to figure out my final answer. So the probability that z is between negative 0.56 and 1.81 is 0.9649 minus 0.2827, which is 0.6, hold on. Six, seven, seven, two. Okay. I may have gotten this last value incorrect in looking at my notes here, but you get the general idea. Okay. All right, so give me a sec because we've got two more, but we're going to do these working backwards, right? So give me a moment to reset, and then I will see you back here momentarily. All right, y'all. Okay, so these last two problems here are work backwards problems, okay? Meaning that rather than being given a z value or an x value like we are here, we are instead given an area or a percentage. We have to work backwards to find our z value, okay? So we're still going to start by sketching out the curve, okay, where I still have my mean is 0 and my standard deviation is 1, okay. The 20th percentile is around here, okay, and what that means is this area here that's shaded in blue is 0.2 or 20%, okay, and I want to know the z value associated with the 20th percentile. Okay, so the way that I'm going to do that is I'm going to go into my normal chart here, and I'm going to look, instead of looking on the outskirts to find a z value, I'm going to look inside the main bulk to find the probability that's as close to 0.2 as possible. Okay, and that number, that probability is right here. 0.2005. That's as close to 0.2 as we can get. Okay, so there's my probability. So I have to then go backwards, work backwards to figure out what that z value is. So I'm going to read over to the left to get the tenths place, and then read up to get the hundredths place. So that z value is negative 0.84. Okay. Right? And that is it. Like, that's my z value. Okay. So if you are like writing this out for yourself, okay, essentially what you're finding is, oh my gosh, sorry guys, I'm getting so many notifications at once. So we found the area closest to 0.2 from the z table is 0.2005, okay? And the z value at 0.2005 is negative 0.84. Okay, and that's it. Okay, so for this last one, okay, again, we're still going to sketch, right? I'm trying to find 45% of observations that are greater than that value. Okay, so my mean is still 0, my standard deviation is still 1. 45% of observations greater than z would put my z about right there. And this shaded area right here is 0.45. So I'm going to go into my z table and look for the number that's the probability that is as close as I can to negative to 0.55. Now you may be going, okay, why 0.55? Okay, remember that the z table is only going to give you areas to the left. Okay, so if there's 45% to the right, then that means there's 55% to the left. Okay, so I'm going to scroll over and find the value that's as close to 0.55 as I can, okay, which looks like is this value right here, 0.5517, okay, and my z value associated with that is 0.13, okay, so right, so my area closest to 0.55 is 0.5517, okay? The z value at 0.5517 is 0.13. Okay? Remember, again, this value right here is your z. It's not a probability, it's your z value, okay? This, right, same thing, is your z value. It's not a probability. Right? Because in these problems, we started with the probability. Okay. All right. So I'm going to tell you briefly about how to work the technology for this. And then that will be the end of this video. So I will gotta reset my screen and everything. Be right back. All right, y'all. So here is our technology corner. So on your calculator, your TI Inspire calculator, you have the ability to find these probabilities using the calculator rather than using a Z table, okay? If you use your calculator, you will get exact values. So your Z table is going to give you values that are very, 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 very close, okay? But may not be exactly exact, right? Because a table would be too big if we listed every single possible like probability, right? But your calculator can do that for you. It has that kind of computing power. So there's a couple of extra pieces of the technology corner up here as like a reminder of how to create and put data into the calculator and like run statistics on it. Okay, but what we want to focus on is these right here. Okay, so the way that you get there, okay, is you always press menu, and then you're usually looking at statistics or maybe probability, then distributions, that's your calculator path. Okay, if you want to find if you want to find a probability, so like the first three examples that I did from a z-score, you use this command, normal CDF. Okay, and like I said, I'm going to post a video made by another teacher that will walk you through this step by step. Okay, if you want to find a z-score, okay, you use, and so that's like this last two that I did here, where you start with a probability and you're looking for a z-score. your command is inverse normal, okay? The best times to use your calculator commands are when you're finding a between probability, because for a between probability, you have to find two values in the z-table, and that takes a little bit of time, okay? Or when you're working backwards, okay? Because this command, inverse normal, is going to give you a more accurate z value than if you use the z table. Okay, if you use the z table, you're still correct, right? Like the AP readers know that some people like to use the calculators and others like to use the normal distribution chart. So it's up to you which one you want to use, whether you use the table or the um, or the calculator to find your probabilities. You still have to sketch, right? You still have to do these sketches, right? And and label and all that stuff and shade the area that you're concerned with. Okay, the reason that you have to do that is because one, it's just good practice to make sure that you're calculating the right values. But also, it's helpful because if you plug something into your calculator incorrectly or you read the z table incorrectly, at the very least, the AP readers know that you knew what you were talking about and you knew which area you were looking for or which z score you were trying to find, so that that way you can still get a lot of partial points on those problems, even if you don't get the answer exactly right. Okay, so that is it for this video. In the next video, I'm going to talk to you about the normal probability plot briefly, and I'll do a couple more Z problem examples. And then I'm going to make one more video for you a little bit later with some sample free response questions for normal distributions, as well as some of the percentile stuff that we did in the last section. All right, so I will see you guys in the next video. Bye, everybody.